Good afternoon, everyone. I extend to you a very warm welcome to today's session. I sincerely hope that all of you are in the best of your health. I am Khwahish from Economic Times and your host for today's session. Today's panel discussion will be on the topic Accelerating Product Development through Digitalization, organized by Siemens and ET Auto. But before we get started, I would like to take a couple of minutes to set the context and then bring in our speakers to get the discussion rolling. Today's product and production processes are becoming increasingly complex. The things company leaders need to consider span from quality, personalized product to being cost-effective, agile, and more sustainable. Complexity is a common theme, and it is growing exponentially. Today, companies in product development need to worry about electronics and software along with the mechanical components. In today's session, we aim to unfold all the various possibilities of using digital technologies and how digitalization can help you manage these complexities in product development while accelerating your product development process. And to enlighten us further on that topic, we have with us today very experienced veterans. I would now like to introduce this eminent panel to all of you. First, we have with us Mr. Deb Mukherjee, Managing Director, Omega Psyche Mobility. Next, we have with us Mr. Mohanraj Ramaswamy, Founder and CEO, Srivaru Motors. Then we have with us Mr. Ayyappan Ramamurthy, Technical Director, Siemens Digital Industry Software. Next, we have with us Mr. Mobin Joseph, Portfolio Leader, Product Lifecycle Management, Siemens Digital Industry Software. And at last, we have with us Mr. Sumantra Bibhuti Baruha, Consulting Editor, ET Auto, who shall also be the moderator for this panel. Welcome, gentlemen. And with this, I kindly request Mr. Sumantra to take over and lead the discussion forward.
Thank you very much, Khwahish, for the warm welcome address and the round of introduction. Again, a warm welcome to all dignitaries in the panel and to all attendees to this very special virtual roundtable discussion. And as Khwahish said, yes, complexity is a common theme in this disruptive era across sectors, I would say, and automobile is perhaps a little bit more when it comes to complexity and disruption. And that's where our focus of the discussion will be on today over the next close to about an hour. So we will discuss about how digitalization can help in managing these complexities in product development particularly, and also accelerate the product development process, because as we all know, product life cycles are shrinking. It's been a trend, and perhaps it's accelerating also to some extent. And especially in this emerging electric mobility era, things are moving, as one of our dignitaries a little while ago said, in electrifying pace. So once again, it's my pleasure and honor to play the role of the moderator in this roundtable discussion. So once again, a warm welcome, Dr. Deb, Mohan, and Mr. Ayyappan. Thank you very much for sparing your time to be in this panel discussion. And to all the attendees, thank you very much for joining. I'm sure you will find this panel discussion followed by a technical presentation absolutely insightful and informative, and therefore very valuable for you. But also at the same time, I would like to place a request to please share your queries, take advantage of this session, of the presence of all the industry senior industry representatives in this panel. So make the most of it over the next hour and a half. And with that, I would like to start the discussion. Starting with Mohanraj Ramaswamy, as Khwaish, my colleague, introduced him. He is the founder and CEO of Shivar Motors. Well, perhaps Shivar Motors is not a household name yet, but based in Coimbatore, it happens to be India's first electric motorcycle maker. First maker in the sense that it launched India's first electric motorcycle. A low profile, maintains a low profile there, but some interesting stuff happening there. And talking about Mohan himself, not many may know that he is also an ex-Tesla professional. So Mohan, in terms, sticking to today's theme of accelerating product development, tell us, I mean, you have seen what in your previous role in the US, perhaps the most haloed startup in the global industry. And now you yourself have founded a startup. How are you leveraging digitalization in terms of to address the challenges, not only to address the challenges, but also to ensure that the time to market is as less as possible, but at the same time, when it comes to quality, durability, consistency in production, it's right top notch.
Thank you. First of all, thank you, Sumantra, and also the entire team for arranging for this call. I'm so pleased to meet my fellow panelists and the members and the participant. It's always a pleasure to meet people who have either taken a similar journey or wanted to be in a similar journey or trying to learn more about things. It's always fun. Thank you again. So going into the accelerating change or the product development and how do we leverage? See, the time before the social media spread and news can be printed in a paper, after a week also it will still be a fresh news depending on where the paper got delivered, right? You can talk about, say, something happened in one state of one corner of India. You can print about it in an article, newspaper. After a week, it still get delivered, and people will say, "Wow, did you know that this happened?" But we all know what happens now, right? If something happened, if you're talking about it after 8 hours, people would say, "Yeah, I know it. I know about it. What a big deal," right? That puts a lot of pressure on the product development. Why? What happened in the news earlier now happens in the product features also. Say, if for example, if somebody even announced a product which they claimed that it will run on some fuel, for example, I think today the biggest trend that talking is on the fuel cell, right? Even though we have a zero fuel cell station, zero fuel cell recharge feature, but if your product roadmap doesn't talk about fuel cell, you're outdated, right? So that's how the customer expectation is, because everything is fast. Now, as a company, how do we leverage? Because everybody knows about these things are coming, they also happen to be humans reading the same social media networks. The component developers are also ready for the change, right? Earlier, if you're trying to develop something, you need to kind of write a presentation about it, then go to them, talk to them, and explain the whole gamut of thing. But now, because everybody is updated, you can just say the product features what you're looking for, they would contribute to make it better. So that acceleration is phenomenal. I think in the co-creation world, which we are very much into, because we cannot make an EV just by ourselves. We needed like 30 other people to make every components and every technology to make it work. So it's very, very good. Now, the biggest challenge with this so much changing thing is mindset change, right? In automobile industry, predominantly, people have something called a resale value, right? They buy a vehicle for, say, 1 lakh or 1.5 lakhs or whatever the price. They would have spent 2 lakhs on the petrol for the life of it. But then they sell it for 15,000 rupees or 20,000 rupees. They brag about 20,000 rupees. That, hey, my vehicle held a resale value of pretty good, right? But in a net totality, any account person would say their total cost was vehicle price times the fuel price, or plus the fuel price minus whatever they got back. So probably in a net, they lost probably 3 lakhs, right? That mindset we have to change to the user. That's a lot of things on the industry people to kind of educate user, start thinking about, hey, don't worry about the 15,000-20,000 rupees what you get after 5 years, but think about how much you're spending out of your pocket every day. Instead of waiting for your results to come on your annuity or to get your pension after you retire, how about I give you incentive on the day one? Save it today, right? So that mindset is, it's very hard, but that is what has to happen. Why? Because no vehicle what is in the market today will not exist after 10 years. I can guarantee you that. The faster change on the technology, faster change on controllers, whatever the controllers, whatever the battery we use today, 10 years from now, it's antique, right? So it's a fundamentally a different way of thinking. Don't wait for 10 years to get your ROI. Get your ROI in 3 years and be done with it. Be ready to use next time.
Even the battery technology which you're using in your own motorcycle today could be obsolete even 4 or 5 years down the line with the kind of developments that are taking shape in various laboratories.
Correct. Absolutely, right? So we'll have to see kind of reduce, reuse, and recycle, right? That approach has to be done. See, the battery itself might have a life longer in a specific case of battery, but it cannot live a life in the battlefield, which is an automobile. Right? Maybe it takes a retirement job, it takes an office job rather than being a Jawan and the soldier after 35, right? It's like that, right? So we just have to deploy it in other place. So the accelerating change is going to impact everybody, especially in the new era. People understand that just like their phone, nobody expects iPhone to work after a year and a half. Yeah. You'll have to get used to that in the automobile.
In such a scenario, Mohan, because it's accelerating, how are you leveraging? Are you leveraging digital technologies any different than what it has been leveraged in the say traditional industry?
Yes. Yeah. I'm coming to the next point, right? Because the products are going to be short-lived, so we'll have to use everything digital, reduce your the cost of inventory. You have to increase your inventory cycle, meaning return on assets. You have to increase return on assets. There is no way I can claim, hey, this product will eventually give me return on assets and I can hold on to it. You can't, right? So what we have done predominantly is deploy the mechanism what is used in the semiconductor world. Because if you look at the semiconductor world, they are a pioneer of change, right? Whatever Intel worked on today's processor, ask them after 18 months, they will say, what processor you're talking about, right? They're used to that. The whole supply chain works like that. Even the same parts, you go to the shop, you get, earlier it was $100, now maybe it's like $25, right? Because they're trying to get rid of it. So we are using that in the automobile also. It is disruptive in the sense 2 ways. One, even our partner cannot say, hey, I will just not invest on R&D, I'll just sit on, be my contractor mindset. It's not going to work. Because if I had to give the contracting to somebody, and if they are able to make money, I can always find a capital to put the plant myself, right? So we'll have to be always ready on that. Second, educate customer that don't expect, I already mentioned about 15 years ROI don't exist. On the company point of view and the co-creation point of view, work with SMEs to develop the new product. For example, I think when the Tesla came up with the LED lighting with the indicator, that was the first lighting came out, right? It only took 3 years. Now there is not even a single car without LED light and the indicators. Not even a single brand has it, right? Did everybody develop their own? No. Everybody worked with 3 or 4 people who did a light for Tesla, right? So we just have to use that. Okay. So,
that's an interesting anecdote that you shared. Let me get another perspective, another player from the EV space. But that's perhaps where the commonality ends between Subaru Motors and Omega City Mobility, because Omega City Mobility has grand plans. It has started, but it has started off with the 3-wheeler space. To some extent, it has a presence in 2-wheelers also, but prime focus is 3-wheelers. And as I understand, it is very soon it will have electric trucks also, and perhaps followed by electric passenger vehicles. So, Dr. Deb, I mean, ladies and gentlemen who may not be aware, familiar with Dr. Deb, Dr. Deb has seen, is one of the very fortunate few to see the entire transition from the 80s, the industry of the 80s in India to now, and going ahead, how disruptive it is. It has also already become, and it is bigger, going to be even more so perhaps. So no, he's one of the fortunate few to see the kind of transition that the industry has gone through. And so Dr. Dev, what are the key challenges that you're facing when it comes to product development, planning, and even manufacturing, I would say, and considering that you're not focusing, unlike Shiva Motors, only on one segment, you are focusing on multiple segments, and these are very crucial segments, and therefore the margin for error is very less, if not nil. So the challenges that you're facing, and how are you kind of leveraging digital technologies to address them?
Yeah, thank you very much, Sumantro. It's really a pleasure being on the panel, and good to meet fellow panelists from the same industry. So as Mohan pointed out, so these new technologies, they will become more and more prominent, and the product life cycles are becoming shorter and shorter, and it is and a lot of these technologies are going to be industry agnostics. Typically in the auto industry, we are used to working with long life cycles of at least 10-year life for a program, etc. Particularly also I'm talking more in the context of India. So that all is going to change, and it is going to change very, very fast, faster than many people imagine. I think the things that are happening in the Indian auto industry is that we are quite in sync with the global industry on the EV. I firmly believe that India has arrived on the EV, global scenario. And, if you take globally, Europe, of course, after the pandemic is kind of leading the charge for transformation. US is kind of course, Tesla has been a phenomenal.
But unlike the traditional industry, there isn't a gap of decades.
No, there is not.
Everyone is more or less in the same phase.
Absolutely. So I'm not saying that we have become something like China, not at that scale, but there is a clear visibility, and I must compliment the government and the whole the agencies who are setting this roadmap. Even a couple of days ago, there is a news government is going to buy 50,000 buses. It's a humongous number. You need maybe 10 gigawatt or 20 gigawatt hours of battery. But yes, the vision should be there, and it has to be a bold vision, and not like this small incremental 5%, 10% kind of change that we are generally used to in our lives, in anything India does. So this is something that is incredible, and I think it has to be applauded. Somebody has that vision. Of course, next comes, how. Once you say what, but next is how. Kaise karenge? Yes, that's something that we need to talk about. We need to debate, and all the stakeholders has to come together. Now, coming to your question, the way we have set up this business, Omega Seki Private Limited is a new company. We set it up in 2018, and then 2020 we launched the vehicle. But unfortunately, immediately after that, pandemic happened, and that was a challenge, because pandemic is something which is never taught in any MBA class so far. So nobody knew how to really go about it, and imagine countries shutting down altogether. So I think what it has brought for a company like us is that we have our roadmap, that in this period of, let's say, next 5 years, what are the products we are going to be doing, and what are the technologies leading to this product line for us. And also for us, global business is a very important part of our business plan. Now, the challenges you talk about, obviously, keeping pace with this rapid change is a challenge. How to do it, there is, and how to have a complete supply chain integrated to it. Today, for example, there is no battery maker, there is no cell maker, there are very, very few powertrain makers, etc. So we are putting this whole supply chain together. We have a JV with a Korean partner for doing the powertrains. We will be doing our own powertrains. We are also at a very advanced level discussion with a global company for doing battery packs. So we will have our own battery packs. We have another alliance with a very large company for doing four-wheeler trucks. So the point here is not these alliances. These alliances were done even pre-EV also. Yeah. The difference here is that, you know, a company like us, we believe that we are a company. I mean, the group company has a 52-year-old history, so we are not really somebody like Mohan or you know, who is young and who has all the you know, experience of working with somebody like Tesla. So we are not a startup like him. I wish I was 25 years younger, but I'm not. So the point I'm making is that for us, you know, we are not a tech native company, to say we are not tech born, you know, but we decided that we have to be technology led company. If you can't be tech born, then you can take the path of leading your business along with the technology. And fortunately, now we have products, we have software, we have the packages, we have simulation tools, etc., wherein an integrated digitalized supply chain. And when I talk supply chain, I'm not talking only about the manufacturing supply chain. It was there, you know, like ERP was there for a very long time. But now this whole, you know, leading to this I4 or digital era, the meaning of supply chain, digital supply chain has completely changed. Okay, we can get customer voice, we can integrate it into the product that we are planning. We can have digital simulation, etc., and some you know, design work which used to be done in, you know, for example, in a year or a year and a half, it can be done inside a month. You know, the whole product development can be done. So capturing all that in an integrated manner is something that, you know, we are doing. But as I said, you know, this whole supply, setting up the supply chain, the links of this supply chain takes time. And we have to work with alliances, partners. You know, Siemens is a great company having fantastic products, etc. I think this is where, you know, constant learning, constant upgradation, keeping yourself abreast of, and also learning from alliances and partners is a challenge which many legacy companies or traditional companies will find difficult. So I think we have to, you know, we have to know what is going on around the world. And it was like, you know, computer was earlier like a computing device, then it became a memory device, then integrated, then communication came in. And once that is sorted out, then it opened up, you know, enormous opportunities. Today, your cell phone is a movie theater, it's a commerce enabler, anything you can do, you know, it's so this is what disruption does. It destroys several other industries. And this is where this is happening now in automotive industry. Automotive has been pretty kind of a traditionally, you know, kind of industry. We are used to working on processes and systems, and Japanese brought this whole just-in-time. Now just-in-time has gone out of the window. People are talking about stacking inventories because there is a huge disruption of supply chain, right? So these are the challenges which will become more and more prominent in days and years to come. And I think every company has to set its own digital roadmap, its own technology roadmap. They will do its own way. You know, what works for me may not work for somebody else. So I think this is the challenge. And to me, you know, today, future is a design problem. You know, what I imagine for my future, it's just a design problem for me, you know, and the complexities that you build into it, the mathematical model that you do, that's how you design your future. And that is where this whole technology element comes in.
And you rightly said, Dr. Dev, having a digital roadmap for sustainable growth is no longer an option. It is absolutely critical. And as you also said, that not many, in fact, most companies in the current space are not born technology. Even though the industry, I mean, the automotive industry has always been a technology landscape for technology, canvas for technology, but the automobile and even the entire process, manufacturing, so it's becoming even more technology, heavy, technology intensive. Yes. And therefore, the role of technology companies or technology suppliers I think they are more than just suppliers now. They have to play the role of enablers also.
Yes.
And that's where I think companies like Siemens have a very, very crucial role to play. So at this stage, let me bring in Mr. Ayappan to share how has, I mean, Siemens is it's not they come into the space yesterday. It's been there for decades and very well entrenched into processes of the traditional industry and playing a very crucial role there as well, the supply chain and whatnot. But in the new age, in this disruptive era, how are you kind of, if I may use the word, reinventing or not really reinventing, but adding new dimensions to the role that you have been playing in the industry so far?
Thank you, Sumantro, and nicely put. Where Siemens, 170-year-old company, and we keep continuously reinventing ourselves, and we've been proud to be a part of what we say the industry 2.0, 3.0. When we introduced the motors back in the 80s, 1870s, and then in fact the first cable between London and Kolkata was done by Siemens. That was in 1885. So on the history, so we keep reinventing along. When we looked at the digital coming in as a major force, we started back in 2008 to be while we have been working for long, but 2007-8 with the disruptions happening, so there was an opportunity to think and do what is going to be the future, the 5-year roadmap. Things happen, and that is where the digitalization, at least inside Siemens, take a more formative shape, and then along with the ecosystems and the German government, you had the 2010 the industry 4.0 coming in more way. So that is when it started. And what we looked at is when we say as could be the holistic way of looking at a digital enterprise. And when you look at this, then the multidisciplinary and the differentiation happens in the electronics and software, electrical electronics and the software. The mechanical and the quality is inherently given, so you cannot be in the industry without that. But what differentiates between is going to be the electronics and the software side of it. So while we had the digital as a platform for years, then we also actually augmented our capabilities with the acquisition of Mentor Graphics. Mentor Graphics brought in all the electrical and electronics, and they are able to give a complete portfolio or as an enterprise portfolio where engineering industries, automotive companies looking at the future where you are able to have a single digital thread working through the conceptual stage, as well as what we call as the model-based systems engineering, model in loop, software in loop, systems in loop, so on. And who could parallelly take the mechanical stream as well as the electronics and software. We also acquired Polarian to because the way the application lifecycle management works and the product lifecycle management. So there is a huge amount of interplay, the amount of software which goes in the frequency and the updates which need to happen. So that becomes more a visionary where we are able to bring in all these capabilities. To add to that is, in the recent years, what we also done, enhanced the complete digital twin portfolio. So what we believe is, how close we are able to create the digital twin, both from the product side of it, the production side of it, and the service aspect of it, with all the technology drivers. You have the artificial intelligence and the variety of data analytics, everything comes in. And all this, how we are going to bring insight. So you have individual set of technologies, and then you have the enterprise applications like the ERP, PLM, SCMs, all that. Now, how you have a single digital thread, which we could bring it, and the importance of having ERP as a key player while enabling the digital transformation through the PLM. So that became an important factor where we had the relationship with SAP. So you have a common business relationship where what we are able to offer, together with the customers is integrated digital thread. So now from the business side of it, you're able to get into the engineering, into the digital supply chain, into the digital manufacturing, to manufacturing operations management, and also with the digital logistics. So you're able to have a complete experience with the digital enterprise. And all this, covered in a layer where we see that everything is, application oriented, so or appification or app factory, as people may call. So the low code, no code application, which actually gets into variety of technologies and have a single face to it, so that the front end for anyone is, is an app, but it connects into your electrical, electronics, or your cost systems or the ERP systems, and
the foundation is the same.
Sit across that's basically happening with our Mendix application, where we are able to integrate it across through the complete digital enterprise with. So this action happened, and the advantage what we had is you're able to start early, and that actually gave us a huge advantage in the market, where you're able to see that at least we are able to be there 3 years, at least 3 to 5 years ahead over the competitors. Sumantro.
Well, I don't know if either Omega Seki Mobility or Shibaru Motors is a customer yet for Siemens, but Dr. Dev, Mr. Ayappan talked about talked about digital twin, which is a increasingly leveraged practice in the industry in order to save time, and also to leverage digital technologies to have to kind of help in the accelerating product development. At Omega Seki Mobility also, are you increasingly kind of tapping or practicing leveraging digital technologies to have digital twins for your product development?
Yes, as I said, Sumantro, we are working with multiple alliance partners, and one of our technology partner on the powertrain as well as on the truck, they are Korean companies, and they extensively use some of these cutting edge technologies like digital twin, and also simulation tools for the product the simulation, etc., and you get results in a very, very quick time. So two things happen once you use these kind of digital tools. One is the accuracy of the result is very, very high accurate. Otherwise you are relying on your knowledge, experience, etc., but that element is taken care of, and the whole data takes over, or the software takes over. So you have a very high level of accuracy. Secondly, the speed of development is very, very high. We work with IIT Guwahati and IIT Jammu also, and we worked on a program where a motor design, for example, which would usually take about 6 to 8 months, using machine learning, using these optimization techniques, etc. The whole model gives results in 5 minutes. 5 minutes. So this is the future. This is what we are talking about. So these digital technology package, if I see, and the whole usage for automotive could be in 4 or 5 segments. One is this whole product development, where you get the customer voice, also competitor landscape, etc., and then you design your own product, simulate it, test it, do all the durability, life cycle testing, etc., etc., and then you have the final result. That's one. Second is the whole manufacturing supply chain, the whole digitalized supply chain, and you can know what is going on where, and if some disruption is going to happen. So without waiting it to happen, it will red flag. The system would red flag and tell you, hey, you're going to have a stoppage here, you're going to have a problem. So that's the whole manufacturing part of it. And then third is very important, is like our friend from Siemens talked about, is the whole product life cycle management. The whole, particularly in case of EV, EV vehicle, it's not a vehicle running on electricity. People have to understand that it is something. When cars came, people thought it's a faster horse, but actually it is not. So same way, I believe that EV is going. It should be seen as a differentiated product and technology from the IC car, in terms of a more like an energy carrier or energy delivery device, something like that. And this is where the industry is moving. So I think this is where a lot of these technologies like digital twin will come into play, where not only the performance, but also the application part of the actual product on the road can be, you will track it real-time basis, and also make the changes, like my friend from Tesla, they do all the over-the-air updates, and they can adjust the height of the shock absorber and things like that. And that's phenomenal. Who can imagine, like, you get a patch and in your cell phone and the car configuration changes. But this is what is the
and thanks to software technology, even physical components are getting smart. They're getting
any
smart.
physical component can be made smarter.
Yes.
Even a glass of water, you can make a smart glass. It can tell the kitchen that I'm run out of water, please fill up. So
Yes.
so that's done. But the whole application part is important. As I said, the computing power, the memory, the intelligence, and IoT and communication, when it got packed together, then everything was sorted out. Now it is up to the engineers to find out where you can use it. Okay.
Yeah.
So,
and so let me pose that question to another engineer, Mohan. With this increasing need and the increasing usage of digital tools, even simulation, the one concern in the mind also is of variation or the mismatch, potential mismatch of real world results and the ones which you get on the machine. So how has it, what's the change you have observed, with the advancement of all the digital technologies? Has that kind of gap reduced, or are you being able to do a lot more validation than what you used to do earlier, and in your whole product development life cycle?
Yeah, that's actually a very interesting question. And that's a very challenge. It's in a two-part answer, right? Anything which was earlier measured with the data specific, they're able to do faster, right? That is given, faster technology, faster. There is a very interesting phenomena on the user experience side. With a year and a half of Pranas on the road, we learn different data, which is some of them are not some. So there's a one thing, anything you touches with the people's feeling, there's a huge difference between actual data and the real data. The actual, there's a huge difference between what is happening on the ground versus what the system says versus what user says. Huge difference. I'll give a classic example. Pre-Prana, average riding motorcycle speed is 60 kilometers. Even if they have a nicest motorcycle, 60 kilometers is a normal kind of benchmark. Post Prana, there are people who ride Prana at over 90, 120, right? But the interesting thing is they come back and say that, sir, I drove at 55.
But the digital technology gives it away.
That is a huge challenge for us, right? Because now you have to perception things managed. Yesterday, ICICI Bank was here and the person from the team was saying, sir, I was coming here, I was driving on my sports bike. I'm a rash driver. I was driving fast and there was a bike coming up to comfortably at the same speed as me, but not making any sound. Then I was turning around and looking, what was it? It was a Prana, right? And that guy drove it on our test track. He said, I touched 90, but I felt like 60. Nothing more, right?
That was that perception, the speed.
Yeah, see, when the people associate the speed, they always associate with the instability.
Yeah, and also with the sound in the conventional ICE vehicle.
Sound and this sound is certainly to some extent, it's most of the time it's to do with how their sensory organs work. When they feel the vibration, they
Yes.
think something is moving. Right? This problem happens with me and my other cars, right? Comfortable 100 miles per hour, don't even feel it unless you have to stop it. Then you realize it was too fast, right? So that problem is there. So we are trying to, we are actually, that is a challenge. We are trying to work on some of the mitigating factors because I don't want it to resolve to conventional answers. which is give a sound to the vehicle, right? Because to me, sound is a pollution. I sincerely feel sound is a pollution. So I don't want to resolve sound to be the way of giving. So we are still working on it. There are some of the things we are ideating on the tool chests are how do we make users feel what they're doing without deteriorating experience, right? When I think in the automobile world, it was said, right? When the car speed increased, it was not when the cars were found. When they found the ABS braking system, the disc brake system, that's when the car speed increased because you can stop it faster, right? So that's the same problem we have it with Prana. So that's one area. The other area is managing with the FUD, right? A lot of people ask, sir, why not give an OLE display, all this data like RPM and all? To me, my dear, I have all the data in my iPhone. Like, if I go into general display specification, iPhone tells all the stats. Believe it or not, I never want to look at the data, nor I wanted to know about that, right? All I wanted is I want my phone to work. When I can make my expectation that simple and straightforward, I think my customer have entitlement to have that, right? So in a nutshell, what I'm trying to say there is this product just should work, should communicate intuitively what it's trying to say to them directly. I think one of the other challenge, which I think the whole industry is underestimating, is the security risk of it. They don't know what can be done. I used to be long time ago a hacker, right? So I know what can be done. So that is something. When we were in Tesla, we put so much security measures behind every connected car system. In automobile two-wheelers, we can't afford that. Meaning it's too expensive, more expensive than the vehicle itself. Why would you do that, right? So we still have to kind of find a nice sweet spot between the security compromise versus the product, right? So that's the same thing what I was saying earlier about the vehicle product, right? When we tagline the Prana, we said fast, fun, and safe. And people said, why are you so much paranoid about the safety? Like we paranoid on the safety of the braking systems, we paranoid about the safety of the battery and all. But 2 years from then to now, 2 months back, everybody was talking about automobile battery safety because we know that can happen, right? So we already identified that as the area to work on, and we made it in our tagline. That means we know how to address it, right? So that's what in our next change, how do we bridge the user's feeling versus what the real data? The system speaks one language, so that one is okay.
Maybe we can build in some interventions, product safety interventions now built into the product without taking away from the experience of the riding. Correct.
It may be some sort of simple systems like how when you finish your food, like you get a bill. It's like that. Maybe after your trip, you probably get a text saying that, hey, by the way, your ride speed was blah blah.
Yeah, right. Mr. Ayappan, in the current EV industry, safety is, of course, safety is critical in the conventional automotive industry also, but given the nature of the technology, the battery technology, it's perhaps a little bit more, especially since the industry is in a nascent stage. One is safety, the other one is the security part. The more physical to digital transition happens or shift happens, there are much more efficiency, much better productivity, without a doubt. But at the same time, there's also a growing potential vulnerability to security, cybersecurity. So what are the measures being taken to ensure that only the good part of the shift happens and not any unintended challenges?
Yeah, you're right. The security is a huge challenge, and you can see it from all three levels. The area where if you are looking at a design within the design environment, how you protect it, that is one level. Second is you look at how you are doing in your shop floor. So from the manufacturing side of it, because the factories are connected, you have a connected factory. And the third one is the end state level, or end state at the service or operations, at all three levels. So, and each of this are the requirements, the behavior, everything is completely different. So, and the technologies which need to be applied also are very different. So when we look at, say, for example, design. So when you look at design, so how, and the need for collaboration is immense. So the people are working from anywhere. The same organizations, whom we are seeing, as well as any of the modern organization, the people are not in same location. Distributed across the geography. There are a lot of people who are coming outside the country who are participating in the product development, and there are technology partners who are there. How do you have access to the right technology and right data, so that the wrong person do not interfere or pilferage and do any sort of thing. So at that level, where we have more from a even at the data level, so what we call as a data in motion security. So which basically there are various kind of technologies which are there protect from a design and a data sensitivity. So for example, Bajaj Auto uses. So Bajaj Auto uses where even if they can share to anyone across and you can copy, still unless the complete transparency is there available in the form of who is using it at what laptop and what he is doing is just copied, and the information is also get into the server, so that there is a high level of transparency available. And if there is then the intelligence comes into play, then it is in the hand of, so if it is treated with the learning capabilities, then you also can alert and say that what is happening. Or by default, without the acknowledgement from the server at the OEM level, you're not able to have an access to those data. Now, moving into the manufacturing level, because the products and data are connected, because the machines, the vendors who are supply, they actually have a remote condition monitoring and variety of things getting inside, and also for making it the higher level of uptime, and you want to service that. So all that is so there is a lot of advantage, but there is a disadvantage where your data as well as the control at certain points also could be compromised for if you don't have the right securities in place. So there is the data security and applications is a separate division in itself to actually have a security audit for the connected factory. So they're able to look at what are all the possible breaches which could happen, and what kind of actions could be taken more from a hardware perspective, software perspective, the connectivity, the network, and how what are the mitigative actions, and also the processes, because still there is a connection which exists. So there is a hacking, then whatever is the known methods, you will be able to prevent it. But probably you could also look at what are the unknown methods which are possible, but that is a level where you'll be able to get. And another very critical aspect is the user level at the operations and the service level. So here you have, and that is where you need the still there is a long way to go. So long way to go more in terms of either when you want to have the 5G and the 6G, because every action, so you do more and more security, then you are processing, and the you want to have a sensor and it needs to get connected, and you have a vehicle to vehicle communication, and you start checking with the security. By the time the action what is need to be taken, you already crossed that action. It is not that it is it is possible, but it needs to be the multi-attribute balancing. So you have to do that, and at the edge level, how are you going to do that, and keeping the security in place? So all these technologies are there. There's a lot are done, but it is still evolving, and we need quite a distance to go as well, because all the technologies are changing so dynamically. So this will keep updating. I won't say a place where it say that okay, it is all complete. So as the technologies progresses, the the ability to provide security in all these areas will increase as well.
As the technology progresses, and also and we also discussed earlier about the continuing trend of shrinkage of product life cycle. Can you just share with us in terms of how much more can the product development process be accelerated through, or let's say, put it this way, how much more can digital technologies contribute towards further accelerating the product development process with only the intended results.
Okay, so very, very interesting, because when we say 15 years back or 20 years back, when you look at things, it is all about the incremental change and the Kaizen and the the improvements what we could do at every level. Even the IC engine, you want to do a 1% improvement in the efficiency or 2% improvement. Now, what you're talking about is not those percentages. It is about multiple times. Are you looking at 200 times and 300 times? Because that is where you're going to have your differentiation. So, the technologies actually play a huge role in doing that. So, in terms of both design, say what we call as the generative design. So the generative design, what you are doing with your electrical and electronics systems, because that is a huge play which is there. So the generative engineering gives that level of jump, where you are able to push these productivities much faster, even in mechanical design. So moving away from the way with what we call as the convergent and the generative engineering, which means you give the parameters and you ask the software to evolve a design which is optimized, so that you are doing more advanced level rather than design the way conventionally extrude, protrude, intersect, and create your sheet metal or your casting components. But generative is a way which is changing the way level of productivity and the level of optimization that you are looking at. And the complexity side of it, you are actually looking at the model-based systems engineering. And what we do specifically is to give that level of productivity, you also do with our engineering services. So that's basically where you're able to transfer these technologies to our customers as well.
Shrinking product life cycles. Let me take a few questions that the attendees have put up. One of them is related to that, saying that why we are saying about that the life cycle of cars is coming down from maybe 10 to 15 years to about 2 to 6 years now. Is it not out of sync with the global efforts of environmental agencies to reduce wastage and carbon footprints? Thanks, Mohan, for answering some of part of this question. But I believe while maybe Dr. Deb, you would like to take this up. Is it in contrast to what the global efforts of environmental agencies are? I believe it has to look in a different way, right? Because now, even with the product life cycle, product development is also keeping in mind high sustainability, and therefore, though there are new models, but these are maybe in the same platform. So there's, unlike in earlier cases, there isn't much of platform changes. It's more of maybe the kind of body styles and things like that. Yeah. So maybe you can throw some light, more light on that.
Yeah, I think Sumantro, see this whole issue of environment impact by automotive, or for that reason, any equipment that you use, should be seen in a holistic manner. See, one is the emission or impact on the environment that you have during the manufacture of the product. Okay, so the materials that go into it. For example, ethical mining, for batteries is an issue. Yes, so researchers have come up with something where you don't use these kind of materials, and industry is moving towards that. And future they will come up with many more such options. So that's something that the environmental impact you are doing, or you are having to create or to make that product. So that's one. Second is the impact during the life cycle of that product that is in use. For example, the tailpipe emission. So obviously in EV there is no tailpipe emission. So there it is. You can say that it scores there. Then third is the end of the life. Okay, so what happens? Once the vehicle is scrapped, then what happens? So I think in these three phases, this whole issue of environmental impact has to be taken up, and whatever efforts have to be done. They have to be done in these three special segments. So you can't say that, okay, I had zero emission during the life of the vehicle, so after that I don't care. So it's not like that. Okay, so the end of life treatment of vehicle is extremely important. And I keep saying that, particularly in the context of India, we never had a law, we never had also a system to sort of recycle, reclaim this thing. So this has got to change, because it's a very hazardous kind of material like battery that you are using. Two, these are not endless supply of material, so certain percentage of it has to go back to the supply chain. Okay, so that's where the whole planning has to start. And also very important, this is where technology comes in. And I would again quote Tesla. You see that they have come up with now hugely and completely unthinkable idea of aluminum this body shell. Okay, so half the car is made in one stroke. So, and probably he will come up with the one shot full car maybe. Okay, so aluminum is highly recyclable, so the whole thing goes again, can be melted and reclaimed, etc. So this is where these technologies and the whole imagination and application of that imagination comes in. You can use these technologies to do the same way, reclaiming materials from the batteries. How will you?
So are you already factoring in some of these ideas into the products that you have launched, are about to launch?
Yes. Our focus has been a lot on the recycling side right from the beginning, and I fully endorse the view that government should make OEMs responsible for it. But again, the challenges would be, how will you track it? How will you know that vehicle has ended up maybe accident or end of life?
I think towards that, I think the direction that the scrappage policy
yes
is a good start.
It's an excellent start.
Very designed, wisely and meets.
No, absolutely. And what I'm saying, of course, practical challenges are there everywhere, but I'm saying that technology can track it. You can track the vehicle even up to the cell level. Tracking is possible. That the battery comes, then is it my cell or it is something else? The user has done it. Battery pack can be mismatched, etc., etc. But technologies are there today. So what I'm saying is, this whole the value of the recycling, reclamation, etc., is enormous, which was not so much taken care of during the IC era. But in EV, I think this is a huge opportunity for the industry to come up now. Okay, and of course it needs investments and infrastructure, etc. So we understand that, but this is where it is important to have a calibrated approach in all the three segments that I mentioned.
And I think partly also this change transformation is also partly thanks to the much higher level of penetration of technology into the automotive industry.
Yes.
Across the chain, and within that software and digital technologies, because the more software and technology or digital technology being used, let's say you talked about tracking and traceability. So that is possible only with this, with the digital technologies, for sure. So so there, I think with that, gentlemen, we have reached the end of this very interesting session of discussion around the theme of accelerating product development through digitalization. So, indeed, these are extremely interesting and at the same time highly disruptive and innovative times. And in that, we have very clearly kind of learned from the dignitaries on the panel how digital technologies is playing a key role of enabling the industry to be not only more advanced, but also, or perhaps I would say, more valuable in terms of and sustainability in terms of environment friendliness and other aspects of it. So thank you once again, Dr. Dev Mukherjee, Managing Director, Omega Seiki Mobility, Mr. Mohanraj Ramaswamy, Founder and CEO, Shivar Motors, Mr. Ayappam Ramamurthy, Technical Director, Siemens Digital Industries Software. Thank you very much to all the attendees. I hope you found this session as insightful and informative and valuable as I found it for myself. And on that note, thank you once again. And now it's back to my colleague, Fahid. Thank you very much.
Thank you, gentlemen, for such an insightful session. We gathered quite some interesting learnings from the panel. Next, we have an insightful presentation by Mr. Mobin Joseph, Portfolio Leader, Product Lifecycle Management, Siemens Digital Industries Software, who shall be presenting on the topic Accelerated Product Development through Digitalization. With that, over to you, Mr. Mobin, for the presentation.
Yeah, thanks, Kwahish. Good afternoon, everyone. I hope that you had a great learning from the interesting insights provided by the panelists. So today, what I'll do is I'll be talking about accelerated product development through digitalization, while the panel discussed upon the ways in which some of them are using digital technologies. I will delve deep into the detailed aspects of it. I'll talk about the key levers and which kind of technologies that you can use when it comes to accelerating the product development. A brief introduction about myself. I'm a mechanical engineer and an MBA with specialization in operations and information technology. I have a rich experience in product development while I was working with Bosch, which is one of the largest tier 1 suppliers in the world, both for the traditional setup as well as in the EVs. Let's look at some of the themes which are driving the industry today in the automotive industry. If you look at the automotive industry, we speak about autonomous. So when we say autonomous, there are various levels of autonomous technology, right? We talk about ADAS level 2, 3, 4, 5, and so on. But what it means is an increase in sensor engineering. It means more complex functions, newer systems, or advanced technologies in terms of suspension, in terms of braking, in terms of steering, as well as new possibilities of interior design. Right? When the more autonomous we talk about, we are looking at how we can reconfigure or optimize the interior, the vehicle interiors as well. On top of that, we talk about electrification. So there is increased electromechanical complexities that increase. There is battery packaging and thermal management, which becomes very, very critical and important. You see what is happening. You hear news about the vehicle catching fires. So it's all because of how you are able to manage the thermal management, especially during the summers in India or in other regions. There is commoditization of powertrain components. So as one of the esteemed panelists mentioned, that they rely on some of the key technical powertrain providers, where there are 4 or 5 vendors in the market, and the powertrain is becoming more like a commodity. On top of that, there are newer NVH challenges. Right? So once the engine noise from your IC engines are gone, what else is making noise? Is the tires, right, or certain other components? Earlier, these things were masked by the IC engine noise, but now there is more focus on newer NVH challenges. Along with that, the requirements are changing. There is focus on climate change, and that is affecting your regulatory requirements, your homologation requirements. There are stricter enforcements. So if there is some issue on the product, there are more fines, there are more penalties, right? And also the expectation of the customers are changing. People are looking at more flexible products. They are looking at more customizable products or more connected products. Similarly, globalization is increasing. We talk about concurrent engineering. So you have so many cases where the technology is being built in, mechanical parts are outsourced to India. The electrical or the electronic parts are developed in Germany, and then the vehicle is produced somewhere else. It could be Vietnam, or it could be some central European country. Right. Similarly, there is increased collaboration between different players in the market. You see so many collaborative news which is coming up that XYZ has formed a partnership with someone else to collaborate on a new kind of technology. Plus, there is an increase in these skill sets or the kind of resources that people are looking at. Plus, it has become more democratized, which means that if you are a good skilled resource, does not matter whether you are sitting in Bangalore or you're sitting in Pune or somewhere else. If you are a good resource, the companies will definitely hire. Right, so overall, the customer and industry needs are changing faster than the product innovation, and that can be launched into the market. So in short, what it means is that there is an explosion of complexity. We are talking about highly quality products, better quality products, flexible manufacturing, efficient products, as well as cost effective. And what it eventually means is that we are talking about smart systems, more integration between electrical, mechanical, and software components. We talk about new materials. The panelists were mentioning about the car body, which is, now we are talking about aluminum bodies as well, which has its own benefits. We talk about new manufacturing methods. We are moving away from the traditional methods of manufacturing to newer methods, the additive manufacturing, for example, which helps in improving the cost of the product. It helps in reducing the substance which is used. And also with this ensures that the technical requirements, the functional requirements are met. We also see a cultural demand for technology. Today, when someone is going to buy a vehicle, be it a two-wheeler or a four-wheeler, they look at how much technology is loaded into it. Right. So people are more interested in knowing what are the kind of features, etc., which are available. The other aspect is also the regulatory requirements, which are improving day by day. And if you look at the future of transportation, who will own it? Whether it will be the technology companies or the traditional OEM. If we talk about the autonomous driving vehicles which are there today, only 3 out of the 20 AV companies are core automotive OEMs. Which means that there is a shift which is happening in the industry. People are seeing that with the change in technology, there's new players who are entering into the market. So you need to evolve because if you carry on with the traditional methodology, the traditional processes, there could be a possibility that someone can enter and replace you. Plus, there is a rapid pace of innovation, right? So if we talk, say, from the computer era, you had the mainframe and then you had the standalone PC. So these systems used to be there, or these technologies used to be there for significant period of time, right? So it used to be there for decades. But now what is happening is that the technology life cycle is getting shorter and shorter, which means that there is the pace of innovation is faster, and which also means that you need to evolve faster, you need to develop your products faster. But what is happening today is that we still work in the manner that we used to work in the past 10 to 15 years. Earlier, there was the mechanical department who used to work on the product design. But now you have the electronic, you have the software development team. So you have different, you have more departments or more stakeholders, but still the methodology of working remains the same. And with this, it means that there are wrong requirements, there is wasted time, there is cost overruns, there is high warranty cost. Eventually, it leads to loss of business. So this is a challenge which is happening, which the industry is facing. So the question arises: can you continue with the existing technology to develop the next generation of vehicles? say today, the CAD tools that you're using, 10 years back, 15 years back, probably the same CAD tools were being used, right? Similarly, when it comes to simulation. So is there something new that you can use? So instead of buying a CAD tool to create a design, can you change the question? Can you look at the possibility of getting a CAD tool or a simulation tool, which will help you in creating a better design, or it helps you in simulating faster? So let us look at these aspects in the next few slides. So from an accelerated product development approach, what is it that you need? What you need first is to have a flexible, integrated platform which helps you in enabling collaboration across disciplines. Today, the mechanical team cannot come out with a vehicle without the support from the electrical or the electronics team. The software teams, which they're developing for the vehicle, they cannot go into the market unless the product is developed, right? So all these different disciplines need to collaborate and work together. Second thing is that we talk about AI, artificial intelligence. We talk about machine learning. How are we using these technologies today? Right? So Ayyappan mentioned about generative design, which means that if the requirements are there, if the parameters are there, we can input those parameters and let the software come out with 5 possible designs through AI, through ML. Like instead of us creating the design and taking 1 day, 2 days, 5 days, if you just enter the right parameters, if you enter the right requirements, the right outputs that you are looking at, the softwares today are capable enough to come out with the different design possibilities. Similarly, can you combine your design and simulation? Like today also, the engineers create the design, then they give it to the simulation engineer. There is pre-processing, post-processing. Maybe the data gets changed from what it comes from the design. Right? But if you can integrate your design and simulation together, it can also improve or accelerate your product development. Similarly, if you're able to do early verification using virtual simulation, and when I talk about virtual simulation, I'm not talking about just the 3D or the structural simulation or the flow simulation. We have tools which can help you do simulation based on the first principle, or we call it 1D simulation, right? When the requirements are in the form of mathematical models, right? So you can start doing simulations at the concept stage itself before creating a 3D and then doing a simulation. Right? So this early verification can help you in accelerating your product development process. And then also how you can fully integrate all these solutions together. Have the mechanical part, the electronic, the electrical part all come together. Because at the end of the day, it's the vehicle cannot come out without an integration of all these parts. So we'll get into the details of these areas. For the lack of time, I will not get into in depth into these areas. So how we have broken down the entire product life cycle is into 4 different phases. We call it the definition, where you start with the requirements management or the requirements which are required to develop the product. The concept stage, where you start with the high level concept of the product. Once the concept stage is done, then you start with the simulation or the development phase, where you talk about simulation, you talk about the design for manufacturability or DFM, design for assembly, variation analysis, and the manufacturing methodology, and then the verification and validation. So when we talk about the definition phase, what ideally we need to accelerate is an information backbone, which is able to link your product requirements to the digital thread. Or you should ensure that the product requirements is meeting the product that you're developing. You should have a single source of truth. What it means is that today, as a design engineer, if he designs and releases, say, version V1, maybe manufacturing may not have that version. Or tomorrow, if he releases V2, manufacturing may not know that he has released the right version. Right? So if you are still managing your entire documentation processes in your folders as silos, there are possibilities of errors. So if you're able to manage your entire information in a platform, where it forms a single source of truth, it helps you in good traceability, auditability. It helps you in easy to operate and deploy. Right. So from a compliance perspective, you are able to manage your standards, policies, rules, regulations, and so on. So this is where PLM, or product lifecycle management solutions, come into play. So a PLM helps you in managing your entire product lifecycle process from start to end. It helps you in managing your entire electrical, mechanical, software bill of material. You can have a good design management of both MCAD, that is mechanical CAD, as well as electronic CAD. Plus, the data is available for the entire ecosystem. So today, if a production engineer, he would want to see how the 3D of a part looks, he has to come to the design engineer, right? But because he does not have access to a 3D tool. But why is that required? If you have a PLM in place, there is good downstream use of 3D data. A quality engineer can view it. The procurement team, as well as the manufacturing team, all of them will have access to 3D data, which is again controlled based on your organization's access control. Plus, you are able to manage your costs better if you have a good PLM solution. When it comes to the concept stage, we talk about interior concepts, body concepts for the vehicle, right? So how the concepts are built, we create a digital mock-up, compliance, ergonomics, safety. When it comes to body concepts, the body concepts are created based on regulations, body structure, and then you do certain optimization, look at the manufacturability, and then you do certain simulations around it. But today the components consist of both electrical, mechanical, and electrical parts, right? So why do we rely on design of engineering? We have solutions which can help you in doing the complete design optimization. There is intelligent design space exploration tools, where depending on the kind of outputs that you need, you can set in parameters, and then it provides you various different product configurations, right? And then based on these, depending on what you need, you can select. The system will give you probably 4 or 5 relevant outputs which you're looking at, and then you can use that to further fine tune the product. Similarly, we talk about generative engineering, right? So with generative engineering, it's not required for the engineers to start creating the parts from scratch, draw, protrude, and so on. Just by giving the parameters, the input and the output parameters, you are able to create, or the software is able to throw intelligent design. And then as an engineer, you can select the right design for you. So gone are the days when the design engineer is a drafter, right? Today, when we talk about a design engineer, we talk about the engineering aspect of it. So let's use technology to provide the designs. The technologies or the softwares today are quite capable enough. And then the time, and then the engineers can leverage their time to see out of these designs, which one of them is more suitable for their organization. The third part is on the development side of it. So when we talk about development, I'm mainly focusing on how you can leverage your CAE simulation. So today, what happens is that there is the CAD which is prepared, then it's sent to the simulation engineer who does pre-processing, then they do the simulation, and then there's post-processing. But the customer's expectation is to have a push button where from the CAD, once the CAD is created, he just pushes it, and then the entire simulation is done, and he gets the result on the simulation result, along with certain optimization requirements or outputs that these things can be optimized to better the design or certain recommendations. And you have solutions which will enable you to do. So with adoption of these kinds of solutions, it will help you in accelerating again your product development. So at Siemens, we have NX, which helps you in not only creating the designs, but also helps you in validating these designs along with our simulation portfolio. Lastly, we talk about the verification and validation phase. And there we talk about multiple different technologies which are there. We talk about ADAS, we talk about thermal management, we talk about aerodynamics and water management, right? So even such things can be done on a simulation, even water management for that matter. Say, for example, you are developing a rear view mirror, and you need to see that if the vehicle is going at a certain speed through a pothole, and if water or mud splashes, does that affect the camera or the sensor which is available on the rear view mirror? And those things can also be simulated.
Which are available, and Siemens provides you an easy to use, open and integrated offering to accelerate your product development, to accelerate your digital transformation. And Siemens is an open ecosystem. We have various solutions across different domains, be it design, be it manufacturing, be it PLM. We are one of the leaders in the PLM segment, and we provide our customers the flexibility to use our solutions in the way that they want. If they're looking at a private cloud, they are free to go ahead with that, or deploy these solutions on-prem or on public cloud. Along with that, we are able to provide them managed services, cloud-ready solutions. So before I get into the next slides, I just wanted to have a quick poll. Team, if you can probably pull out the poll. So while the team is coming out with a short poll, where I would request your support to answer. I will just take you through a couple of customers on how they have used Siemens' solution, why they chose Siemens, right? So we talk about Daimler, which is both into car as well as truck manufacturing. And they use our PLM solutions, they use our CAD as well as electrical as well as electronic, or electrical as well as mechanical CAD. And with our technology, they have seen a 44% reduction in time. Like earlier, when they used to take 1.5 years to come out with the product. Today, through digitalization, they're able to come out in, say, 10 months. And so if OEMs are able to reduce, right, it automatically puts pressure on the suppliers to reduce their lead times, right? So as the OEMs start adopting these technologies to accelerate the product development, there will be a tremendous stress on the suppliers as well to adopt these technologies. Because if they don't, then they are not able to provide the solutions on time to the OEMs. Similarly, if we talk about about one of our other customer, ZF. So they are using our electronic CAD solution, and it has helped them in achieving a 20 to 50% reduction in the design cycle time. Right. So these solutions, these technologies, if you procure and adopt well, they're able to accelerate your product development. You are able to reduce your design cycle time, right? And there are live examples of customers both in India as well as globally who have seen the benefits of using these technologies. So next few slides, I'm just going to conclude. Just wanted to add that the electrical light did not come from continuous improvement of candles, right? So if we still talk about continuous improvement of increasing our efficiency by 1%, 2%, adding 2 resources, 3 resources, and seeing how better we can improve our design process or simulation process, it will only take you to a certain extent. But from there, you need to have a paradigm shift. So tomorrow, when you're going and speaking to a CAD vendor, or you're planning to select a CAD tool, the question should not be about whether I have a design person who is able to work on that CAD tool. The question should be how much improvement that particular CAD tool can provide me. This is my current design process, right? So you have vendors in the market. You should go and talk to vendors and ask what is the kind of business problem that you can solve for me. So when you're coming to Siemens, if you come to Siemens and say that I'm looking at buying an NX solution, or I'm coming and I want to procure a simulation solution, we will be able to provide you. But if you come and ask and say that, see, this is the business challenge that I have. I have a design cycle of say 12 months. Can you help me in reducing that to 8 months? Or can you help me in reducing that to 7 months? That is where we as Siemens can provide you more value compared to anyone else. And that is because we have close to 400 plus solutions. We speak to so many people both in the Indian market as well as global market. So next time when you're speaking to anyone, as vendors, as technology service providers, solution providers, if you talk from the business side of it, that, hey, how can you help me in reducing my cycle time, or how can you help me in improving my efficiency or throughput, we may be in a position to come up with better solutions for you. Just to summarize, when we speak about accelerated product development, what it means is that improving speed that you can do by automated generative design, having virtual prove out through simulations, having an integrated manner of working through PLM, through data managed backbone, as well as have regulatory compliances, have solutions which will help you in having good requirements and verification management, traceability, auditability, and so on. And with these kinds of levers, we feel that you will be in a position to accelerate your product development with the right kind of technology and with the right kind of technology partner. So with that, I end my presentation. If there are any questions, I am please feel free to answer. Probably we have extended the time by 1 minute. Probably we can have 1 or 2 questions, and then we can reach out to us separately as well.
Thank you, Mr. Mubin, for such an insightful presentation. With that, we will now quickly move on to our Q&A session. So the first question that we have from our audience is, how is Siemens helping startups adopt digitalization and help in their product development?
Right. So when we discuss with startups, right, we typically have a very consultative approach towards them. So we discuss with them and understand what is it that they're trying to solve, and then look at the different kind of technology that will help them in achieving those targets. Right. Along with that, we have some special programs for the startups. We have some special bundles targeted towards startup, which will enable them to develop products faster, plus at significantly lower cost. Right. So we understand that startups have certain limitations when it comes to funding, certain limitations when it comes to the money that they can spend on solutions. So from that perspective, we have very good programs or very good, I would say, product bundles focused on startups. And with that, we have, in India, we have been working with a large number of partners, not only in the automotive space, but also in the space technology, with the drone startups, space startups, as well as startups in the automation.
That was quite insightful. With that, we move on to our next question, which is systems such as PLM, etc., are very expensive and difficult to implement. How is Siemens addressing this?
Yeah, so Siemens has a large experience when it comes to PLM. The company which we acquired, which was UGS, that was the first company to bring out PLM into the market. But in the last few years, and with the feedback of the industry, it was that the traditional methodology of implementing PLM used to be very expensive. So because of that, we are now also offering PLM on the cloud, which we call Teamcenter X, which is a software as a service option. With so much of experience in the PLM, and with so much of experience with the industry players, what we have also done is we have pre-configured this PLM based on the best industry practice. So with these new PLM offerings from Siemens, it can help you in adopting a PLM faster at probably 1/3 of the cost which you would have spent, say, 5 years or 10 years back.
Very interesting. And the last question is, technologies such as self-driving cars and ADAS will take a long time to come to India. Why should Indian companies focus on these technologies today?
Yeah, so that's a very interesting question. But what I would say is that, see, the self-driving cars as such may come to India, or India may not be ready for the self-driving cars today, right? But the Indian suppliers are providing, or we are looking at, providing or exporting our solutions to these players in the other market who are developing the autonomous vehicles and so on. So even though India is not ready, the Indian suppliers should be ready to create these technologies, which they can then build and then provide to the global OEMs.
Very valid point stated by Mr. Mohan. With that, we come to the end of today's webinar. Thank you, speakers, once again for taking out time and being with us today. I hope all of you found this event insightful and engaging as much as we enjoyed putting it all together. Before we wrap up, Team Economic Times wishes all our audiences safety and the best of health. Have a great evening ahead.